Welcome back, dear students. We are discussing some important questions which are from electricity, current and electricity. We have discussed some most important questions which are linked with these topics. So here we are proceeding for the next few important questions. Here it is. The loop rule is based on the conservation of energy principle and junction rule on conservation of charge principle. So here it is. Conservation of energy and conservation of charge. To explain just how these are based on these principle, If you look at according to loop rule by the Kirchhoff law, we have sum of the EMF that is equal to sum of IR. Basically, it is basically if you sum up the total potential that is equal to the EMF. The IR is basically potential. So the left hand side equation shows that the work done by the source of EMF used to impart electric potential energy to the charge, while the right hand side, this one, shows that the dissipation of acquired energy as a charge passes through the resistive medium. In other words, if we say that the gain in energy is equal to the loss in energy as required by the law of conservation of energy, thus the loop rule of the Kirchhoff voltage law is manifestation of the law of conservation of energy. So here it is, Kirchhoff law is explaining how the energy is conserved, how it follows the law of conservation of the energy. On left side, if you look at, this is the total amount of the work done by the battery or the source to, to impart electrical potential energy to the charges. And to this electrical potential energy, these charges are able to move from one terminal to the other terminal through the conductor. So that dissipation of the energy as charge falls through the resistive medium. So that's why it falls during the resistive medium. On the other hand, we can say that the gain in energy is equal to the loss in energy. And sometimes it is energy is gained from the EMF of the source. So when it is moving through the conductor, it is lost to do some work, and this is used to do some work. So it means one amount of energy is converted into another amount of the energy. So it is in accordance with law of conservation of the energy. Thus, the loop or Kirchhoff's voltage law is manifestation of law of conservation of energy. So here it is, from where the charge is getting some amount of energy and where this charge is using this amount of energy to overcome that type of the repulsive forces, the resistive forces of the medium. So the next one, it is the energy conservation. So the next one is according to junction rule, the Kirchhoff's law, we have total current entering a junction, that is the total current leaving the junction. So it is also explained on the basis of Kirchhoff's law. So if you look at, we know that the current represents the flow of charges per unit time. That is I is equal to Q divided by time. Thus, in terms of charge, we can say that no charge can accumulate a junction. In other words, we can say that the total charge entering a junction per unit time must be equal to the total charge leaving the junction per unit time. So thus the junction rule is manifestation of conservation of the charges. So if you look at, there are two laws of the Kirchhoff. One is law of conservation of the energy. The other one is law of conservation of the charge. Whatsoever the amount of the charges are entering to a junction, same amount of charges will be leaving from the junction. So it is proved by the Kirchhoff's second rule, and in accordance of the Kirchhoff's junction rule, the second rule, we came to know that there is a concept of conservation of the charges, and here's the definition of the current charges flowing per unit time. That's whatsoever the number of charges are flowing inside of the junction, that will be the same whatsoever the amount of the charges that are flowing out of the junction. So this is incarnate of the Kirchhoff's second rule of the law. This was the first one where energy is constant. So here is the second one where the charges are constant. So these types of the questions are explained on the basis of Kirchhoff's voltage law. Here it is. Another question, that is why a rise in temperature of a conductor is accompanied by a rise in resistance. Why the resistance of a conductor increases with the increase of the temperature. The position offered by a conductor to the flow of electric current is known as its resistance. The resistance offered by the conductor to the flow of the electric current is due to the collision. This is the most important key point to understand. Collisions of the electrons with the atoms present and in the lattice of the conductor. So with the rise of the temperature, these atoms will gain energy. And what will happen when they will gain energy? They will vibrate with a larger amplitude, and their rate of collision with the free electrons will increase. As a result, the electron motion will slow down. And so that's why slowing down of the electron is basically increasing of the resistance. As a result, the resistance of the conductor increases. If R naught or naught is the resistance of a conductor at temperature 0 degrees Celsius, then the resistance of the conductor at temperature 0 degrees Celsius will be, this is the temperature resistance at R, and this is the resistance at 0. So here it is directly proportional to the R resistance at 0, the time at that time. And if you replace the proportionality sign with constant, that is alpha, and alpha is R naught T, and this resistance at a certain temperature T, after increasing the temperature, that will be equal to R naught 1 plus alpha T. So alpha is constant known as temperature coefficient of the resistance. So it is basically temperature coefficient of the resistance. It is written with alpha. So if we revise it once again, what happens when we, in case of the conductors, we are only talking with the conductor. We are not discussing this time about other types of the substances. It is reverse. It is totally opposite in case of semiconductors. But in case of conductors, what will happen if we increase the temperature of a conductor? Basically, if we increase the temperature of the conductor, what will happen? The vibrations of the atom will increase. With the increase of the vibration of the atoms at the large, more temperature increase, more the vibration of the atoms will increase up to the large amplitude. With the result, the collision of the free electron with the vibrating atoms with a larger amplitude will increase, which will result in increase in the resistance. So basically electrons become slow down and the resistance increases. This is the most effective technique to understand what will happen with the increase of the temperature in case of the conductor. So that's why the resistance of a conductor at 0 degree and the resistance of a conductor at T degrees Celsius is T and 0 degree. So we have calculated the difference between the two. More will be the change in temperature, more will be the resistance. Less will be the change in temperature, less will be the resistance. So here is the mathematical relation of the resistance with the temperature. And finally, we have discussed about the alpha. It is basically uh, called temperature coefficient of the resistance. I thank you very much for your patience.